DNA is made up of a ribose lacking in oxygen in its 2' group, hence the term deoxyribose, and is connected to a phosphate group by a hydrolytic bond. These form the backbone of the DNA strand, and in a double helix, 2 of these strands are formed anti-parallel from another, which means that one strand faces from 5' to 3', and the other strand goes from 3' to 5'. They're just basically backwards. They're upside down from each other. And what happens next is a origin point forms where the DNA starts to split and forms a bubble. And unfortunately, we couldn't show this because we ran out of pipe cleaners, so just bear with us. So what happens here is this is going to be hard to pronounce, a topoisomerase holds down a replication fork, kind of like the end of a zipper. And usually, again, there's another, but we ran out of strands. And another little protein comes along called helicase, and it unzips the nitrogenous bases from each other. Next, RNA primase comes around, and it's not a he, it's just it, places RNA primers all along the duplication strands. This is because another little protein called DNA polymerase cannot start replicating just on its own. It can't just spontaneously add a nitrogenous base here. It needs something to start on. And fun fact, DNA polymerase needs to go from a 5' to a 3' direction. It's just the way it works. Hence the formation of a leading edge, which is which only has 1 primer on it, and a lagging end, which includes many primers because DNA polymerase has to go backwards on this strand. So when the primers are eventually taken off, they leave these gaps that another DNA polymerase has to come by to fill. Unfortunately, we were running a bit short on time, so we couldn't film this part. So here's a picture of a dog. Just look at it for a little while I finish this up. And the resulting DNA chunks that are formed, they're called Okazaki fragments. And you can't really put on a pair of ripped jeans. You see what I did there? Okay, we're moving on. So another enzyme comes by called ligase, and it seals the fragments together. And finally, this process continues. The strands are ripped apart more and more, and eventually, the bubbles reach each other, and you have 2 perfectly replicated strands of DNA.